Okay, well, I'm going to go ahead and get started. It's about 1 o'clock. Welcome back for the third day of this 5-day event. We're meeting 2 hours every day until we get this done, really. If you see on the web page that I have here, I've got a web page up, and I'm highlighting the address right now for you guys. Every day, if you check on this, I'm going to be posting more and more material every day. So look at the links that are showing here, and there'll be either links to printed material, or if it's under the sample data, there'll actually be some files that you can download to your machine at your convenience and start working with. Those are the same files that I'll be working with during the webinar. Today, I don't have any printed data for you guys, but I do have some other sample data that I'm going to be using once we start talking about building flow grids using the telescoping form. So if you want to go ahead and download those and unzip them, I'll be using that a little bit later on, probably starting around 2 o'clock. I'll try to get to that. I'm limited on my staff help today. I've got one extra guy, and this is his first day. So if we take a little bit extra time getting to your questions, please bear with us. We'll try to get to all of them. I see there's one now. I can, Richard, I can send the link to you by an email. Or if you just go to our SERP website, serp.usace.army.mil, there's some links through the pull-down menus to get there. But yeah, I'll try to send the link out to everyone here. Hopefully that helps. So what we're going to cover today is we're going to go back over a little bit of what we did yesterday, creating the variable space grids and how to recreate them, working with them, trying to get them how you want it to be before you actually start saving and working with the actual grid. So we build the grid frame and like a conceptual representation of our model first in the map module, and then we generate the grid. If it's not what we envision, then we can delete the grid that was created and then restart modifying our map module information and then rebuild again. So that's what I'm going to kind of go over real quick. I don't want to spend too much time on this, but I want to go back over that again. So if we start our SMS, so under the Start menu, the same way I'm doing it every day. So we go in, and the files that we're working with I had put under the CMS -Humboldt directory. And so what we started out with, let me clear this. What we started out with was a merged set of bathymetry. That's kind of what we worked on the first day. So we brought in our bathymetry, and then we started working to build our actual conceptual model. And if you save your project periodically after your model's already been conceptualized in the map data, we loaded a coverage, that information will actually be stored in a file called whatever the name you give it, .map. And you can always load that back in and have access to that again. So I've loaded that back in, dragged it and dropped it to the interface, and you see here that I have a grid frame. I have the scatter points. I'm going to go into display options and show these a little bit different way. So under scatter, I'm turning off the points and turning on the contours and changing them to look at them by a color fill. And then I'm specifying a range just so that I see the same colors pretty much every time I come in and look at bathymetry. So you guys can choose whatever you want, but this is what I prefer. And so once this rebuilds, here's our grid. So I'm also going to go in under the scatter and then contours and give some transparency, 40%, just so that I can help see my grid frame and any kind of refine points that I may have entered. So one of the questions earlier was, once you build a grid, how do you repair it? And I think what that meant was, if you build a grid, what steps do you have to take to make it better? And so basically you would come back in, delete the grid from that's showing up in your data tree, and then work back with your map data and add in more refined points in certain locations, in places where you want to increase the resolution or decrease the resolution. For each refine point, you can right-click and choose Node Attributes and set a refine value, and this is the unit in meters based on that point. And so I'll do that for these 2 points I just added. They don't have to be the same, they can be. So I'm just choosing some numbers that I think are going to work okay in these locations. And then once you're through with any modifications, you can save if you'd like. If you've already saved a project and you want to save another one, you can just choose Save Project and choose the same one we used yesterday. I'll go ahead and do that. It says, yeah, do you want to replace it? And yes, of course. If you've already saved it once, it won't ask you that every time. My other helpers finally showed up, so let me take a second to make them able to help you guys. Okay, now back. So what we're doing is we're basically taking the grid and or the scatter points with our refine points. We have our grid frame here in this purple grid frame, and we can go under Feature Objects and convert that to a 2D grid. I have to go back and set this up again. So we're choosing the bathymetry here, an extrapolation value. I used, I think, -2 yesterday. We can mark any cells above the water column, say 2 meters above that, as land. And I forget what I had for the cell size here. I believe it was, let me go back and use the same values that we had in our notes. Bear with me just a second. So we used refine points. 180 meters is the base cell size that we want in our grid, and we're using 1.08 here and 1.06 here, turning off the intergrowth between the points, and then we can click OK. So after a minute, it will finish that, and we'll have a grid appear in the data tree. We usually will get some kind of a message here, and I wouldn't worry too much about all these nodes and cells that it's talking about. The main part of what it's talking about is that there are many cell strings that are being generated, and also there's some cells that were declared as water that are surrounded by land. I'm going to stop this for just a second and go into some of these questions. I've got 18 questions I need to answer. Hold on just a second. I'm sorry, you guys. I hope that this helps. I had paused the screen at the initial, and so I could do some other working around, and I forgot to unpause that. My apologies there. Hopefully this has cleared all that up. One of my helpers says yes, that is. So I'm going to clear these questions out and we can start back. I'm sorry about this. All right. So hopefully you guys at least were able to hear what I'm saying. I don't want to necessarily start over because we're already going back over something that was covered in depth yesterday. But basically, if we need to work with these cells, we have our map file. It goes back, and every time you build the grid, it wants to reframe to whatever is showing. So let's zoom in here. I kind of went over some of these modifications. If you want to add resolution, you can do that with new refine points and then regenerate your grid. You'll be working with this several times. The message that you got that said lock cells, land lock cells, it actually selected those, and if you wanted to, you could right click on these, selecting the cells, and then right click and actually change those from ocean to inactive land. That just means that they're not going to enter into the computations, and so that will take care of those particular items. So you would do this over and over again, working until you got a decent grid. And so if something was wrong, you didn't like what this looked like, you could delete this grid, go back to your map data, and then do some changes down here, and then rebuild the grid and get it until the point where you want to start, and actually keep that grid and then start with your boundary forcings and things like that. And that's what we're going to cover right now. Let's just go ahead and close this, what I have, and I'm going to load the grid that we used yesterday. So that would be the CM cards file. I actually saved over the project without these loaded, and so if I load that SMS project file, those files should not be there, I think. So let's load that grid. Now that we've got the project loaded, I'll load the individual grid itself with the CM cards extension. We can turn off our scatter set and just zoom into what we want to look at. And so in our case, we've got our grid situated like we want it. Let me see something. Well, this isn't exactly what I wanted, but it's close enough. What I can do is, for these areas here that kind of look strange, we've got some cells that are water that need to be land. Somehow when I did my save just then, it messed that up. So I'm just going to select this. And under Edit, you can select with the polygon. And so I will try this one more time. Select with the polygon, and I'll click out, selecting those cells, and we can make those land. All right, and that looks a little bit better. It's not perfect, but for the purposes of this training, I think it's good enough for right now. So what we started going over yesterday is adding some boundary information, and forcing from the boundary always comes in from cell strings. We covered some of this yesterday. We talked about the various types. We have assigned boundary condition. So we have cross-shore, which I'll get into on Thursday once we start working with a wave grid. We have water surface elevation forcing, and there's certain options here that are available to us. We can define a curve, and if you know the values, or if you have something in an Excel spreadsheet with hours and the values you want to just cut and paste, you can do that. I have a file sitting out there with an XYS extension. That's one that works with CMS, and basically that's where I had previously exported what data I had loaded. So let's load that back in, and you are able to see what the tidal signal looks like for that forcing, and you can click OK. There's some other types of forcing that you can do, one being tidal constituent forcing. You notice right now there's nothing on the right hand side, and basically that's because the tidal constituents we have in another dialog. So if you wanted that, I'll show in a few minutes the location of where those tidal constituents are listed. There's also water surface elevation and velocity forcing. These can only come when you extract from a larger solution. So you'd have a larger grid that has already been run for a certain time period that has developed solution. You can load that and then extract from that. Well, I'm not going to show it. We might show it during the advanced, I'm not sure. But basically, for every cell along this cell string will have its own value instead of using the same one value along the entire cell string. So back to what we were using, we have water surface elevation forcing. I'll click OK. I also shown about designating, let me turn on another option here to show the computational domain. And that kind of helps show the place where the water meets the land, so we can actually do this a little bit better. So let's come in here and we can manually create a cell string, and I'll just choose this location right here. You can't see the cell string yet, but if I had turned some of the contours, made them a little bit transparent, that would help in visualizing that. And so once that's generated, you can select it and assign a boundary condition, and then the option for flow rate forcing is available. You can do like we just did, cut and paste values here, or import from another file as such. So basically that's how you bring in any kind of external forcing from the outside of your domain. So the water would be coming in through this open boundary, being forced as water surface elevation, and then from this land boundary it would be coming in forced as a river flow. So there's other types of forcing too that we might want to do, such as wind forcing or wave forcing. I'll cover those in a little while when we get to those points. But right now we're going to go into this under CMS flow. There's a model control. And in this model control there are several tabs, and these have changed a little bit throughout the couple of years, and it's going to change again in the next version a little bit. But basically all similar things that are going on that you're trying to represent are under its own tab. So for the flow we have a start date and time, some durations for simulation and for the ramp, and basically a ramp duration is a period of reduced forcing at the beginning of the run so that you don't shock your model. It allows the time before all of the forcings build up to their full strength to appropriately build the signals as you get in. So that's what the ramp is. There's a hydrodynamic time step, and normally when you come in and you build your grid for the first time and you're happy with it, the first time you come into model control, a value is normally showing here. And what we generally do, this time step is actually what we consider an explicit time step. So it would be on the order of a second or less. Sometimes you can get by with a little bit more. So we normally take that value, whatever is showing, and half it. So just for right now, I'm going to put in for 1 second, assuming we're going to be an explicit solution. And then I'll cover a little bit more about the difference between implicit and explicit in a few minutes. There's some options for hot starting. If you had started previously and written out a hot start file, you could actually start a new run from the endpoint of that other one, or from whatever time was written to that hot start file. You have an option to specify how many processors are on your computer. And so if you have a laptop like me and you only have 2 processors or 2 cores, you could put the number 2 here, and you would be able to see an increase in performance as you run CMS. So another way to find out if you don't know how many processors that you have on your machine, what you can do is go to your taskbar at the bottom, right click, and there's a task manager that pops up, and click that option. You can go to performance, and whatever number of cores here or CPUs are listed is the maximum number that you can put in that blank. So in my case I have 8. I could put any number from 1 up to 8, and CMS would use most of those cores as it ran to get a little bit more efficient answer, faster answer. Other parameters are water temperature, water density. These aren't really used right now, but they may be in the future. We've got depth to begin drying cells. That's basically how CMS determines which cells are wet and which cells are dry. And so as the water level decreases, when a cell only has 0.05 meters in this case of water left, then internally CMS would declare that cell as dry. It'd be outside of the computational domain for a period of time until the conditions existed when it would have been wet again. And so you would, at that point, CMS would consider it wet, and then it would enter back into all the computations. There's wall friction, different terms here. I would never modify any of these momentum equation terms. Leaving them on gives the best answer, and turning them off doesn't necessarily get a more stable solution. So just leave those on for right now unless you really know what you're doing. See, there's a question. Let me go ahead and answer that. Okay. So that's pretty much all on the flow tab. The sediment tab is basically if you want to run with sediment transport. You notice everything is grayed out right now. If you wanted to run with it, you would check the box, and then you'd have the ability to edit any parameters and choose what types of sediment transport algorithms that you would be running. I'm not really going to get into a whole lot of the sediment transport options. That's going to be covered during the advanced portion next week. But needless to say, if you want to run with it on, then you would calculate sediment transport and be able to modify these values here. I will go into the other aspects of the window, even though I won't show it. Basically, there are 3 time steps that are used by CMS right now. One is a hydrodynamic time step. One is a sediment transport rate time step. In this case, the default is 60 seconds. This is mainly for the explicit solution scheme. For implicit, you only have one basic time step, and that is the hydrodynamic time step. And it will use the same value for all of the other time steps that I'm going to talk about. But for the explicit, since you're running with such a small time step of 1 second or less, you don't necessarily want to calculate sediment transport or morphology change at that same rate. And so we're allowed to give a larger value for the transport rate, 60 seconds. So this value has to be greater than the hydrodynamic time step, and then the morphologic value time step has to be greater than or equal to the transport rate time step. So, and then there's some other options here that we can go into next week. The hard bottom, basically, hard bottom data set is, in some areas of the country there may be a rock undercropping under the sand where the sand can only erode down to a certain point. And this data set for hard bottom is how we designate those areas to be located. So I'll show in a minute how to set those hard bottom values, but to start off with, you have to create a data set first. You see it showed up over here, hard bottom. And when we click OK, there will be another data set that shows up in the data tree. Same thing for D50. D50 is not necessarily needed, but if you have a transport grain size located in this list that you can use, but you could also specify a D50 that is the median grain size for your run, and you could set that, ask you what the default should be, you give it a value, and then when we click OK, that will be represented in your data tree as well. So you've got, for your grid, we've now got 3 different data sets. One's depth, one's hard bottom, and one is D50. So I was mentioning hard bottom earlier. How do you affect the values for this? If you look down here at the bottom, you're seeing a negative 999 everywhere, and basically that's the default value for hard bottom. It essentially tells CMS that for every cell that has a negative 999 as a flag, that CMS can erode as much as it needs to get the answers. But in some places you don't want it to be able to erode that far. Like in Florida, there's a couple of different inlets. One of note is Sebastian Inlet, where throughout the entire inlet throat and back into the back bay there's a rock at the bottom, and you need to model that. And so they have taken some sand samples and figured out what those depths are for the most part, and been able to set some values out here. One thing that you can do, and that we do sometimes, is to, I'll just zoom into a certain area here. To set those values, you would select a cell, and so I'm just going to select some cells around this jetty, for example, to represent maybe the toe of that jetty so that it does not erode. So we could select these cells, hold your shift key down to select multiple cells. As we said yesterday, if you hold your control key down, you can draw an arrow, and every cell that arrow touched would be selected. So that's a little bit easier way to select these cells. And so just for right now, I'm going to stop there and just select those cells. Then you can right click and you can specify a hard bottom, and this gives you a list of choices. And that list of choices is unspecified, which I've just mentioned as the default. It means that it's fully erodible. But a lot of times you either know how much sand is above the bottom, or you know at what depth that rock is located. And so there's different options here to specify that. So if you know what the depth is for that rock to be located, you could specify some value here. And the default value here is the average depth of every cell that's given. But that's normally not what we want. So I'll just specify 16 meters, and It's an arbitrary number because I'm just making this up as I go along, but I'll show you what effect that has on these cells in just a second. So 16 meters, we click OK. So you notice it turns a color here, and it also is given an icon so that you can see from a distance that those have some kind of attribute. And in this case, these are hard bottom cells. So I'll look at one of these cells, and I've chosen that one cell there. You see an S value, and that's basically because I have a hard bottom selected here. This S value is representative of what data set is showing. And for a couple of the data sets, you can actually change this value if you want. Most of the time you cannot. But you see that its actual depth is negative 1.079. That's actually above the water. But we're saying that there's rock at 16 meters below the surface. This probably wasn't the best example, but I wanted to give a little bit of a demonstration here. So as you move around, you can see that the depths are changing with the Z, but the actual depth of the rock is 16 meters. If we chose another couple of cells here, we can specify hard bottom, and we don't know exactly the depth, but we know that because of a sand sample, we know that below where I have the bottom marked, I may have 1.5 meters of sand available to me. So I can choose that option. And when I click OK, it gives them an icon, and it also changes the value. So basically what that did was it takes the depth and it adds 1.5 meters to that for these cells. And so all of these put together will help us in the CMS as far as determining where that bottom is. I see there's a couple of questions I'll try to answer real quick. Can you set an erodibility coefficient for the hard bottom? No coefficient is available right now. The ways that you could do that is you could, if you're using multiple sediment grain sizes, you could actually specify values in this area, in certain areas, with a larger grain size so that it's harder to move. I think Alex would be a better one to ask that question. I see he's already trying to answer at this point. But there's no coefficient, there's just a depth of erodibility, at least right now. Okay, so that's the hard bottom, and essentially the D50 data set is manipulated a little bit of the same way. There's no right-click option because there's, you're just specifying a grain size for certain areas. But what you would do, you'd select a certain number of cells, and then you could change this S value in that location to represent that grain value. And this is not the best way to handle multiple grain sizes. This was a way that we got in there early on as a first effort, and then since then we've gotten true multiple sediment grain sizes, and that will be covered in the advanced portion next week. So I'm going to go ahead and move on to more topics in the CMS flow model parameters, unless there's a question about this real quick. Okay, so going back to the model control, it's under CMS flow model control, and I'll explain some of these other things as well later on. But under model control, we were under the sediment tab. We explained pretty much all of this. There's a simple 2D salinity that's available that I'm not going to go into right now. If we have time, maybe on Thursday afternoon or Friday afternoon, we could come back and answer some questions about this, but this is not really used a whole lot right now. You would need to be in an area where you were in a well-mixed situation. It doesn't do any kind of stratification right now, since it is a simple 2D model. That's hard to do. So, but the same way you would turn it on, you have a time step for salinity calculations, and then you can specify initial conditions for your salinity everywhere. And then there are other ways. Once this is turned on, I'll just briefly go into it. Once that is turned on, then you have an option on all of your boundary conditions about being able to specify an inflow of salinity concentration at that point. So that's all I'm going to really talk about this right now, but we can go over that later on if time permits at the end of the webinar. So back to the model control. I'll turn that back off. I'll turn this off. Remember, I was talking about the boundary conditions, being able to specify tidal constituents. In SMS 11.0, you're limited to 8 different constituents that you can use, and you can turn those on, any one of these or all of them, whichever you want, and you can modify, once they're on, you can modify the amplitude and phase based on a NOAA harmonic analysis chart, or if you know it from some other survey. I'll just go to the NOAA site real quick and show where these might be located. So it's under harmonic constituents. I'll look for California and see if there's one at Humboldt Bay. I can't remember. I don't think there is. Yeah, there's Humboldt Bay. And so there is a harmonic constituent sheet here that basically lists all of the coefficients, and most are either 0 or they're very low energy amplitudes. You want to make sure that you represent, if you're going to use this, use the ones that are the highest amplitude, largest amplitude anyway. And then specify those in here. In the next version, 11.1, we're going to have all of the same constituents loaded here, and you can turn any one of these on or all of them and change the local amplitude and phase. They're only representative of a certain point that's in a nearby area. It may not be the best way to do this if you have an extremely large domain. There are tidal constituent databases that are available for the east and west coast of the United States, as well as the Leprevos database that's available for anywhere in the globe. And if you want to use constituents from that database, you can use, so for the water surface elevation forcing, you would want to extract from a data set using tidal constituents. And there's an option here. I'm not going to show this right now, but basically you'd be able to link up with one of the databases, choose how frequently you want to build a water elevation signal based on those tidal constituents, and then you would end up with a value at every cell along your grid of a representative water level curve for that. Okay, so the next tab is the wind and wave tab. So if you wanted to include winds right now, you would check this box, and in SMS 11.0 you're limited to spatially constant, temporally varying winds. We have some other options available now in the CMS to use variably spaced winds, but they require special cards, and I'm not getting in those this week. We're going to cover this next week probably, or we can. But basically what you would do is you would specify a curve for velocity, same type of series editor that we've seen before. We have an hour and a velocity meters per second. And then you would also specify direction, same thing, hours and direction in degrees. You note this convention. The winds are coming from 0 degrees would be from the north, 90 degrees would be from the east. It's somewhat different than some other conventions, but this is what the CMS is expecting when it reads the directions in this file. You can change the anemometer height. If you have your wind specified with a 5-meter anemometer height, you can specify that. CMS will make all the adjustments that are needed. Wave data. If you perhaps have run waves and they're already mapped to the exact spacing of your CMS grid, which is not a common thing, then you would be able to turn on this wave data, including radiation stresses and the other wave conditions, to be able to force these waves onto your flow grid as time was going through your flow run. I have a note here from Alex Sanchez, who's going to be giving the webinar next week, that the spatially variable winds will be covered next week. But as far as the wave data, normally this is not how we handle input of waves. We handle the waves through a feature called the steering module, which is under data steering module. And that basically says that you have a flow grid, you'll have a wave grid loaded that you've set up all the spectra, and then you'll give it some interval and CMS will run between those two. Hopefully we will definitely be getting to running waves and flow together on Thursday afternoon or Friday morning via the steering module. I have to cover the waves part first before I do that. So let's just skip over to the next tab, which is output. And basically you have 4 different lists of times that you can specify. So you may want to have output from your model, global output, for water surface elevation every hour. And so if you wanted that, you could turn on water surface elevation and associate it with the first times list. And then you could go to the times list and say, I want to start at 0 and end at the end of my run and increment every hour. And what this would do is it would set up a time list and associate that with this water surface elevation. And you could reuse that same time list for any of the other types of output that are listed here, but you're not required to. So a lot of times we get our velocities at 6-minute interval. And so what you could do there is associate velocities with output times 2 and then set up a new time list for every 6 minutes for the entire run, and then your velocity output data set will contain those values in it. And repeat this for all the other types of information you want to get out of the CMS. Make sure that you do set at least one of these times. The default for all of these is none when you come in the very first time, and so if all of these are set to none, regardless if you have specified some output times list, you'll get 0 output. I realize that 6 minutes is pretty short, but if you had a certain time period that you wanted to compare with actual data, you could do that, say, for a shorter time period. But any other time, normally I use half an hour or an hour output. The next tab is for cells, and basically this is observational output on a cell-based output. And so you would specify, I want these types of information to be output. So we have, I don't like the names of these, we're actually reworking this totally for the next version, 11.1. But for now, if you want any kind of hydrodynamic output, meaning velocities or water surface elevations, you would check these boxes and give it a certain rate. If you wanted flow rate information in the X and Y direction, you would specify this, and if you wanted transport rate information, you would specify this particular area. Now that's just turning on the output and specifying an interval. It's not actually saying which cells are going to be giving that information. So to do that, we would come out of this, and similar to what we did earlier, we would zoom into an area where we wanted cell-specific information. We would select a cell, and it might be an equivalent cell that matches up with where a gauge is located, something like that. That would be one of the purposes of this. You would select that cell, right-click, and choose Attributes. And in 11.0, we would specify that as an observation cell, and you could turn on any of these or all of them if you wanted. And hopefully that's clear enough. You can actually give it a name so that you can keep track of what exactly is at that location. Now, this kind of is misleading. It makes you think that observation is a different type of cell. It's not actually a different type. It's still an active ocean cell, but it's also an observation cell. So we're changing this a little bit next version. So when you click OK, we will see that that cell now has an icon associated with it, and anytime you select that cell, you will see, be able to right-click and see that there's some kind of an attribute associated with it. So let's go on to the next tab, which is Input. And this is not really used very much as far as these custom input data sets, but we have the ability to add additional data sets that are cell-specific, kind of like the hard bottom or D50. It could be used for salinity. It could be used for any other value you want. We had thought maybe for vegetation density, something like that. But we're not really using this right now. But we are using the bottom friction data set, which is on this tab. And so you would specify what type of bottom friction computations are being made, whether it's relative to a Manning's or bottom friction coefficient or using a roughness height. So you'd make those choices. Right now it's none selected. The default is for Manning's with a 0.025 value. And so you could click OK. Once you have that, you come out and you have yet another data set that's listed under your tree. If you wanted to go in for a certain area and increase the friction for whatever reason, maybe it's vegetation or it's flow through bridge pilings or things like that, you want to increase the friction, you could, just like we did earlier, you could select a couple of cells, right-click, actually, I'm sorry, select those cells and change this S value at the top. So I wouldn't go too far away from the default value unless you really know what you're doing, but you could modify that value, and then those cells would have a different friction value as opposed to the ones right next to it. Hopefully that's clear enough to explain. There's another question here. Okay, those have all been answered. All right, so we're going on to the next tab. Which is the Advanced tab. And the Advanced tab is what we added basically so we could implement new features in CMS that were able to be turned on and given simple parameters without an immediate need to update the interface. So there are certain things that we'll add and we'll accumulate several of these different new features, and then for the next version of the SMS interface, those will actually have a place among these other tabs. But so that we can use those new features ahead of time and allow others to use them if they're interested, and we give that the advanced cards out, then you can put the information that you need to right here. So what you would do is you would insert a row, and you would go and edit that row, giving some kind of a card name. And one of the first things we used for this was for number of threads. And you just specify the card name and some value, and depending on what we decide what those values are. So we would specify some number, in this case for number of threads. We don't really need this now because since we added, since 11.0, we've now added a place for the number of threads in this location. But that's how you would put new information that's not currently supported by the interface and still be able to use it with the CMS model. So that pretty much covers all of the model control at this point. Are there any questions about anything I haven't covered or you need more information on? I think one of the other things that we haven't really touched on is the explicit and implicit and what the difference is. The explicit solution scheme is really what we first came out with. It has limitations on current, and so your time steps are pretty small, from anywhere from 2 seconds, and we've had some cases where we needed to bring our time step all the way down to, say, 0.25 or 0.2 seconds, and it makes the length of time for these jobs to run extremely long. It's hard for us to work with. So we invested and we started developing an implicit scheme, which is handled a little bit differently for the solutions. It's converging on the solution over the grid. And so we're able now, if you choose an implicit scheme, solution scheme, then you can run with hydrodynamic time steps of anywhere from 5 minutes up to, say, half an hour or maybe even an hour. I wouldn't go too much more than that, but you need to take into consideration all the processes that you need to model in your grid. So if you have areas that are having a lot of wetting and drying, you need to make sure that you're able to represent those so that they don't all dry at one time in one time step or not, just to get the hydrodynamics correct. And so it doesn't make any sense to run an implicit solution scheme with 1 second time steps. That would take a really long time. The way this converges on a solution, it's an iterative process. And so if you're running 1 second or 5 seconds or 20 seconds time step, you might as well go ahead and try running the explicit, which is actually a faster for that smaller time step. And hopefully that's not too confusing there. Alex can go into this a little bit more next week. There's one question: is there a list of items that we can write into the Advanced tab? There are some. We have a wiki that has a lot of the cards that are available in the CMS model, and they don't necessarily say that they go as part of the Advanced tab, but anything that's listed there either has a representative control item on the model control, or you could put that information into the Advanced tab, and hopefully that answers your question. We're working on trying to get the wiki with more cards, more information, easier to find these things, and hopefully within a little bit of time we'll have all that information up there for you. Are there any other questions about the model control at this point? If not, I'm going to move forward to the next item under the CMS Flow tab, pull-down menu, and that's Model Check. And so basically, you would want to run this model check anytime you wanted to make sure that your grid was set up correctly, that you weren't violating something that you weren't supposed to. So it's like a pre-step before the actual model runs, just to make sure that your spacing is not too narrow in some areas, or that certain time steps aren't larger than other time steps, or things like that. So what we could do is under CMS Flow, go into Model Check, and right now it says that cell aspect ratios are outside the recommended range, and this is an old problem. Basically, we're no longer restricted to this description. It says that the long dimension cannot be greater than double the size of the shorter dimension. Basically, we can use ratios from maybe 1 to 6, 1 to 8 without any problem. You don't want to get too much of a smaller ratio than that, but you're no longer limited to 1 to 2. So 1 to 8 would be probably the limit of what I would want to use at this point. And where this really comes into effect is if I turn on the ocean cells, you'll be able to see that when I added resolution inside the inlet throat to represent this, these are nice and square, but as you get out into the deeper water, the shorter dimension, since this resolution has to be carried all the way out to the edges of the domain, the resolution from this side to the other side is getting, or the ratio between the two is getting pretty extreme. And so you can modify that with limiting the maximum cell size that you use for your grid. In this case, it's 180 meters, and this is probably 20 meters across at this point. So you can see that that's a 1 to 9 ratio. So that's where those ratios come into effect. The other check, it says missing salinity specifications. Under the model control, I must have left on calculate salinity, and it didn't know what to do. So if I turn that off and go back through my model check, it's gone now. So it'll list a few things here that you can go back and modify and make sure that everything's situated. And then I would go through and save my project and then actually run. Okay. Is that pretty much straightforward? Any questions about that? Anytime you go under CMS Flow and run within the interface, it will automatically do a model check. Now, if I try to run this right now, since my grid somehow got corrupted earlier with all of this information, it's probably not going to run that well, so I'll not try it. But if you wanted to see how your model was running, one thing you could do is just save your grid and then go in and tell CMS to run. Go through the model checker and you say, okay, I want to ignore that, or I want to fix those, and then click run. It will look in a certain spot to find the executable, and if it can't find it, it'll give you this message and let you browse for it. Another place that you could go is under Edit, into the Preferences. There's a File Locations, and this basically lists where the executables for all the various models are. And you'll note that for CMS we have 3 listed. There's CMS Flow, this would be the implicit version. Then we have CMS Flow Explicit, this would be the explicit version. And then we have CMS Wave, which is only the wave model. You can browse, and by default when you install SMS, these are located in the installation directory under Models, and there's several directories. and then there are basically versions that you can select to use. And so in this case, if you're on a 32-bit machine or 64-bit machine, you could select a certain one to run. And when you tell it to run, it would go and do that. So let me just try this real quick. I'll save my grid. And then I can go in and tell it to run. Ignoring this, I'll run the model. It says it can't find that particular model. In the latest update to SMS 11, they've reorganized where all of the CMS flow models are. And so the version that you guys have might be okay, but I have a little bit later version. And so it's under, let's see, Program Files, SMS 11. So they've reorganized into these directories. Before, there was just a file out here and an explicit directory. So you may see that when you look in your directory structure. So I'll just choose explicit. And then it actually comes out and it starts to run. I don't anticipate that this is going to run because, like I said, I have all these problems with my grid. But it gives you some information, and then all of a sudden it's done. And you know that it was too quick for it to actually have gotten an answer. So you can exit, then you can change and fix any portions of the grid that you might need to. And then try to rerun at a later time. If you choose to run the explicit, it uses one of the versions under explicit. And if you choose to run implicit, it uses an actual different version. So hopefully that's not too confusing. In the next version, SMS 11.1, there'll be one version of SMS that will run both the explicit, both the implicit, and the wave model all together under one, and you don't have all those choices to make. Are there any questions about what we're going over right now? Okay. If there are no more questions, I'm going to stop this, and there's one question here. Mark is asking what the problems are with the grid. And let me show a little bit of what's going on. If I turn off these ocean cells, it's a little bit easier to see. Part of what the problem with this grid is I have all of these cells. You see the lighter blue, and that's because I've turned on the computational domain option. Basically, these are wet, these are dry. I would want to clean all of this up before I started running. Other reasons why it might not be valid is because I was running the explicit model, and it might be that my time step was way too large for the actual spacing and depths and forcing that I have set aside. So a lot of times you'll get some information through the diagnostic file. Let me see if I can show you a little bit. There's a CMS_diag.txt that gives some information about the run. And then if it got very far, there'll be some information here. There was a different error there that caused it to crash just then. But basically, you'll be given some information about what might be going on. You can just do a basic look around your grid and see anything that sticks out like this. Normally, that would be a problem that's very readily seen. You see all the issues up here as well. So you would fix those, try to run again. If it still didn't work, maybe lower your time step a little bit and see if it got a little bit farther. If it did, then normally that would be a current limitation. There's some other things that you could look at as well, but those are the major ones. Hopefully that answered your question for right now. Okay. So I'm going to go ahead and move on. It's 2 o'clock, and we need to be covering creating telescoping grids. So you see the limitation with this particular type of grid, with the resolution having to go all the way out to the extents of the domain into deeper water and all the way across. This adds a lot of extra cells that really aren't needed. You don't need that extra resolution out here. You don't need the resolution for some of these other places in here. If you look on the grid, you can right-click and get, actually you can choose the grid, and under File get some information. And this tells you about how many cells are in this particular grid. And in this case, we've got 217,000 cells in this grid, and that's a huge number. So the smaller this number, the faster the answer that you might be able to get. So you want to really work with your grid and make sure that it's as efficient as possible and that you don't have over resolved areas that you might need. Another way to do it is something that we added over the last year and a half with telescoping type of files. And basically that's what I showed you on Monday. Let me see if I can open that PowerPoint back up and show. Let's see where I put that. Okay, so this shows that you have the resolution that goes all the way out, or else you can have extra resolution that doesn't necessarily extend beyond where you absolutely need it. So I'll show you how to create those type of grids. It's a little bit different in the interface, but you have the same underlying steps that we did before. So for this part of the webinar, I'm going to close everything that's loaded in my grid, in my SMS, and I'll go into the telescoping folder that you guys have, and I'm going to grab the merged bathymetry and bring that in. So I'll turn that on, and I can frame to show it. And it's essentially the same data that we were working with earlier. Let me see if I need to repeat something here. The question is, can I repeat how to enter measured data at a specified point? Let me do that after I create the grid for telescoping, because a lot of the boundary conditions and everything else is the same for both types of grids, so it'll be easier for me to talk about that in just a few minutes. All right, so I've got the data for Shark River. I'm going to go into scatter and turn off the points and look at the contours. All right, and so what we want to do is basically the same thing that we did before. So we need to create a coverage that's for a CMS flow. So you can either use the default coverage, you might want to rename it something that you can remember what is in that actual coverage. and then you can right-click and set the type to be Models CMS Flow. Or if you wanted to keep that and create a new one, you would do what we did the other day and just click New Coverage, give it a name, and then choose CMS Flow in this manner. So I've already got one, so I'll just keep that. So the first thing for building telescoping grids that I would do is, you can do them in any order, but normally I build the domain that I'm going to be using. So that would be done with the grid frame. And you would click a point and you see that it anchors at that spot. Then you can build, extend that inland until where you want it to stop, and then have another click at the end to end and build the rectangle. So it's hard to see that. I'll go back into Scatter, Contours, and give some transparency here. Just as we did the other day, we would select that. We could rotate around the point of origin. You could extend or narrow the grid in any direction that you wanted. And then when you're happy with it, then you can start specifying the zones for resolution. So the difference between telescoping and variably spaced is the way the resolution is described. For the variably spaced grid, you resolve around a point, and for telescoping, you actually specify zones where you're going to have a certain type of resolution. And so to do that, you need to build arcs. And so there's a tool in the map module called Create Feature Arc. And so you would just click that, and then you could use this arc to define regions of where you want to increase your resolution. And what I normally start with is I'll build an arc around where my land is going to be, where I know that my land should be. And one easy way for me to figure that out is, so you can set your scatter display options, the contours, and on the minimum side, which is the land side, wherever you think that you're going to end your land, you can specify a value. So I normally just choose something, between -1 and -2. I think for this particular case I chose -1.4, and I am choosing not to fill below this value. So anything which is higher on land than 1.4 meters above the water, I'm choosing not to fill below it. And then when I click OK, we should see a vastly different grid. So this kind of gives a good area for us to build the first arc for where my land is going to be. So I'll click Create a Feature Arc, and then I'll just start clicking out points around that area. And one thing I've not mentioned yet, I'm zooming around this grid relatively easily, and I really haven't said how I'm doing that. I apologize for that. Basically, on most mice today, there's a scroll ball, and so if you roll that ball up, you're zooming in, and if you roll it out, you're zooming out. And where you're zooming it in and out is based on where your cursor is located on the screen. You could also click that scroll ball down, and then your cursor turns into a hand, and you can drag your screen in whatever direction. So that's how I'm kind of moving about so easily. So hopefully you guys can remember that and practice it. It comes in very handy. So let's start this over again. I'll create an arc. Let me get rid of that one first. So I'll start creating an arc. I don't know why it's okay. And just click the points until the land is described. So if you make a mistake and you get too far in, you can hit your backspace key and actually back up 1 point. And so you can just click this out. And this is a pretty tedious thing, but it really makes a lot of difference to build these zones appropriately for your area. It's not quite as easy to increase the resolution. In some areas you have to add a whole new zone or change the resolution for an area. But what is going on here? All right, so just moving around the edge of what I'm considering to be my land. This will take a little while to keep doing this. But basically, I'm going to speed this up a little bit, so it's not going to be the greatest. I have a map file later that's going to contain a sample zone that you can build. So I'm just going to end this real quick just so I can get to the next point of what I'm trying to talk about here. I think that I am not doing what I need to be doing. I think I'm in the scatter module, and it's not going to be what I want. You want to make sure that you're in the right module. I'm up in the scatter module, so I'm clicking out a break line right now, and that's not exactly what I want to do. So I'm going to switch back to the map module. The tools look alike, and so I think I just answered Lauren's question. It should not be made in the scatter module. It should be made in the map module. And so I'll zoom back in and start working on this again. Just real quick, just so you can get a basic idea of what you want. So I'm going to make this very large, but you get the point. You want to go around where your land is, and it needs to extend outside the domain. You have your box here that's going to specify the domain. You could also specify additional curves inside for other different areas where you want another type of resolution or another spacing in that area. So we'll say for this area, I'll have that. And since this is an island, I'll go ahead and close that arc on itself. You may have other areas that you want to add resolution to represent where there's going to be flow. So you would want to represent all of those with some sort of polygon. There are other ways to create these arcs that are more automated, and we can cover those in just a few minutes. But you'll need a combination of both clicking out these arcs and doing it automatic as well. If you do an automatic creation of these arcs, you normally wind up with many more arcs than you need, and then you have to go through and clean them up. So let me zoom back out. I'll create another arc over here. You might need a certain, I see that I'm going to have a little issue right here, but you might need another resolution to represent these groin fields in this area. And so you can click these out. Basically, you want to represent all the features where you want a certain type of resolution, because you're going to have resolution here, it's going to go up outside of that, and then resolution in other areas. And you just keep making these until you're happy with what the results are. A lot of times you'll follow the edge of your domain for the land area, and then you'll want to specify another range just inside that, because you want your cells close to the land, the shallower items, to be a little bit more resolved than other areas that are out in the middle of a bay or maybe in a flat area. So you're going to have several zones of resolution through this. I mentioned being able to do this automatically, and how you do that is through the scatter module, and it's based on depth. And so what you could do is go to your scatter data, under scatter, let's see, be able to right click on the scatter set and convert scatter contours to map features. So basically this is the other way I was talking about doing this. So if you know you have a certain area inside of your domain that is at, say, 0.75 meters, you could look at what the arcs would look like for that area. You can specify a certain spacing, and you can actually tell it to either join it with an existing, well, I was hoping you could create a new one, but join it to an existing coverage, and then click OK. It'll go out there and it'll automatically create these arcs for you. So it is faster, but you end up with a lot of areas that you might not want to keep. So just be aware of that. You can always go in back to your telescoping grid. If there's certain polygons that were created or arcs that were created that you don't want, you could select them and delete them. Just work with the grid over and over until you get it specified how you want it. What I'm going to do now is remove this map information that I've just hand-drawn and show another one that we've pre-done for you. So I'll clear the coverages, and there's a map already in the same directory, and you can pull and bring that in. And this is one that's closer to what we used for this actual project, but it's not exactly what we used. But you see how we went around the outside where we had the land specified. Just inside from that we have another zone. It's pretty flat in this area. We don't necessarily need any more. So there's a lot of different areas here that we've created. You see that we've increased the resolution across where the ebb jet's coming out, where the ebb shoal is. And once you have these zones created, what you would do, that's not really saying how much resolution to put for each one of these zones. So to do that, you would go under Feature Objects in the Map module, Feature Objects, and Build Polygons. And so that takes all the arcs that have closed on themselves or onto the edges of other arcs and create polygons with those. Then you have an ability to select those polygons. So I'm going to select this one. I can either double click on it and specify a value, or I could right click on it and choose Attributes and specify a value. Just know that the values that you specify in here could be any values you want, but what's actually going to be represented in the grid are by factors of 2. So if you have your largest cell size is 200 meters, well, your smallest cell size is 20 meters, then your other zones of resolution go up by a factor of 2 onto that. So it'll be 20 meters, 40 meters, 80 meters, 160 meters, etc. So you can go through and specify these each individually. You can specify some of these to be, rather than giving a telescoping size, you can say it's not going to be ocean at all, it's actually land. And then when you build the grid in just a few minutes, it will choose that arc and create land cells inside of that. So we can do this real quick. Assuming we've set all of these appropriately, we can go under Feature Objects, Map to 2D Grid, exactly like we did yesterday with the variable space. Give it a largest cell size in this block, and then specify where your depths are coming from, just like we did yesterday. Extrapolation distance or value, and then marking certain cells above the water level as land, and I think we chose 1.4 meters above water as land. So I'll click OK. It comes up and it says, okay, this grid's going to have 4 refinement levels. This is mainly because if you forget to set the value in one of your polygons, you may have a very, very small value there. It's going to choose to create thousands of refinement levels to represent that, and it'll just get stuck in an infinite loop. So we've added this little double check just to make sure that you can stop it before it starts. If this number is really large, then you can say, no, I don't want to continue, and you go and find the ones that you have not set. But for right now, we have a minimum size of 8 meters up to 128 meters with 4 total refinement levels it figures out. And then you say, yes, I'm going to continue. Now, depending on the size of your grid, your domain, the number of cells it's creating, this may take a little while. And these type of grids are more memory intensive than the variable space grids, just the way that they're handled within the SMS. So loading these grids and working with them will take a little bit of extra time in the interface, but they're much fewer number of cells in areas. You don't have greater resolution in areas that you really don't need it. That's what I'm trying to say. All right. And so you get the same messages that you do before. It's dead ends with cell strings and also locked cells. There's 2 identified. And when you come out of this, this is the grid that you have. So I can turn off this map module information. I'll turn off the scatter information. And you can see that I have my grid here. I have land cells where I wanted them. Around the edges, I have cell strings already identified. This was specified as land like I told it to. And so you want to just make sure that everything is represented like you want to. And just like we did for the variable, if it's not right, you need to go back and reiterate, go back to your map data, increase the size of the spacing. There's only a few cells through here, so we might want to increase the resolution a little bit more, just so that there's flow between these 2 parts of the bay. Same thing on the other side. You can increase the resolution in some areas so that we get all the flow that we need. Down in this area, it's only 1 cell wide in a couple of areas. There will be no flow between these whatsoever. And so we need to make sure that we better represent that. And so what we would do is we would come back, we would delete this grid and go back to the drawing board, so to speak, and change the values for these various areas. So we saw that for this area we had specified an 8-meter resolution. We could reduce that down to 5 meters or whatever we thought was appropriate. I've got another coverage that we finished, and this is the actual coverage that we used for this project. So I'll clear the coverages now. I'll zoom back out, and if you go into the grid files, there is a telescoping map.map. Load that particular map file and come back in, and you see it's a lot more complex than what we were just showing. So you can add as much information into these as you need. You see that each one of these groin fields is represented. The jetties are represented. The spacing in this area is now 2 meter spacing so that we have adequate bathymetry through here. Spacing through there. And so you just keep iterating until you're comfortable with what that map file generated as far as the grid. And so I've already generated this grid, so we don't have to take up the time. It takes a little while for this particular one to build. And so I'm just going to load that grid into the interface so that we can see what the final product looked like. So it'll take just a few minutes. Like I said, these grids are pretty large, and the way that they have these multiple layers of resolution, CMS does not really handle that very efficiently in 11.0. They've reworked that in 11.1, which will be coming out later this year. And these grids load much faster, if not 10 times faster than this just did. So now I can turn this back off again, and we'll look at the actual grid here. Eventually. Sorry it's taking so long, but this is a large grid. All right, so I'll switch to depth, and so that we can actually see all the resolution that we have in these areas. So you see how the transition goes from one cell to another to another. There's plenty of cells across these channels to provide flow, and so we would probably be happy with this grid at this point, and we could file, save the project so that we could use this again later on. And so the same options are available under the model control for this type of model as it is for the other model. The only exception to telescoping grids are not available with the explicit solution scheme right now anyway. So for right now, if you want to use a telescoping grid for your project, you must select implicit. Otherwise you'll get a message in the interface. But all the other information here is consistent for implicit type of grid. Everything else is the same. So once again, if you wanted to specify Manning's in, I've already got that for this area. I am trying to work with this grid, and it gives me a message that says the projection for this project must be same as the grid's projection to use this tool. Excuse me. And the reason for that is that remember yesterday I mentioned that we could save our settings for the projections, and so what I did was my projection right now is 901, which is California. Actually, this is Florida East, and what we're wanting to use for this zone is actually New Jersey State Plain. And when you set the projections and build the grids, the projection information is automatically saved with that grid as well. So SMS knew that this grid was supposed to be in a different coordinate system. And so you could actually right-click and tell it to work in the grid projection. And when you do that, it will reorient the grid and set us in the right projection to be working for this grid. I hope that's pretty clear. All right, so now I can look at the depth or the Manning's in. I can select cells and see the values here. If I want to modify these values, what you would do is you would select cells in whatever location that you wanted to modify the Mannings and change the value that is in the S or scalar entry blank. You don't want to mess with the Z because that's your depth. Even though you're selecting Manning's in, if you change this Z value, it's going to change the depth value. So that's how you would modify the Manning's in for this particular one. Same thing if we had values for hard bottom or D50 or whatever loaded right there. And similarly, if we have a cell selected, we could right-click and make that an observation cell for a certain type of output. And then in the interface model control, we could modify the cells output tab to give whatever information we needed and the interval at which we need it for that particular cell. Hopefully I answered all the questions that were posed that I said I would come back and get to. If not, go ahead and ask the questions and we'll try to work through them. Are there any other questions for anything that I've gone over today? I don't necessarily want to get into another topic today. We've only got about 20 minutes left for this particular day of webinar. So ask any questions that you have. If it's something that I covered in a previous session, I can go back over that. If it's something that I covered today, it would make it a little bit easier and more pertinent, but ask any questions that you might want. Hopefully this isn't too much information and I've gone at a decent pace today. I know it's a lot to go over. The question was, can I run a case with this grid right now? Let me go in and try it. So let me see how it was set up in the first place. Let me, I'll remove that observation cell. I'll look at the model control. And we didn't go into all the different blocks here, but you know, when you're specifying the date and time and simulation duration, you need to take into account, you know, how long you're going to be running. A lot of times, if you're running multiple months, it may be hard to figure out how many hours that is. So in the next version, we actually let you specify, I want to run 65 days or 52 weeks, something like that. So it makes it a little bit easier in this area. Also, we're going to be changing the start date and time rather than this type of block. It writes it to the file a little bit strange way. But let's see what we got. We have 4 threads going to be used, 0.05 meter depth, wall friction, no salinity transport, no sediment transport. Let me see what kind of forcing I have. These are all things that you need to make sure that are provided before you start running how it's going to run. So let me look at the boundary condition. It does have a water surface elevation curve associated with it. So I think it's good. I will, just to be on the safe side, I will save the project. I'll just save this as webinar. And I'll go in and make sure that the executable is correct. And now I'll try to run with it. So you can either go in here and run from the interface, and I'll show you how to do that. And so it's running now. And as it's running, it's giving you a little bit of information here. I'll scroll up. So there's information about how the file was set up, parameters, what processes are turned on, the time steps, how many processors are used. And then as it's running, there's more information here about it's writing information out every 0.1 hours, it looks like, giving residual information on pressures, U's and V's. This is for diagnostic information, so you can see how well it's running. You see these iterations are 1, 10, and 20. Basically, like I said, the implicit model goes through several iterations trying to converge on a solution. And so this final number here, 24, 20, whatever it is, was the final one that it actually converged on a solution. There is a maximum number that it wants to converge with. Say, I think it's 40 is the default. And so if it gets to 40 and it still is not converged, this exponent right here might be very small, like e to the minus 4 or 3. You want to make sure that these final iteration values are very, very small numbers. So that's one thing to look at. There was one other question about how to enter measured data at a specific point, and I can cover that either Thursday or Friday when I'm going over post-processing. Would be a better time for that. I misunderstood the question initially. All right, and so it's going to continue to run. This says for 700 hours. Once the run gets to 1% complete, then SMS will give an estimated remaining time so that you know about how long this particular run will take. Another way to do this run, I'm going to go ahead and abort this right now. Another way to do this would be to run it directly from the command prompt. And that's how we normally do it here. Because you're running within the SMS interface and it's monitoring everything that's written to that file and it's taking up memory, it may actually slow down the run of your actual simulation. And if you have multiple of these, you might not want to start an SMS version every time you want to run. You want to actually run these from the command prompt. And so what you can do is just start a command prompt, go to the location where the files are located. So I will have F:, I'll change directory to that location. You'll want to make sure that the executable is in the same directory as where your files are located. So what I'll do is I'll just go and I'll grab the executable that I want to use. So that'd be SMS 11, CMS flow, implicit. And in this directory there are two files. You want to make sure you take both of those and make a copy of those in the directory you want to run from. And then you can actually run that executable with the name of the parameter file. So you can drag and drop these names if you want. I should have actually put a space in there after that last one. Or you can actually just type in the name of the file since you're already in that directory. So either way should work. So what we're doing here is we're running the executable with one argument, and that's a CM card. So that tells CMS to run the flow model, and because there's a card inside there that says run implicit, it will choose the implicit model. And so this should be exactly the same as what we were seeing before, but it may actually be a little bit faster. Does this answer your question, Mark? Okay. Are there any other questions about what we've gone over or anything else I could cover during today's session? If not, I think that's all we're going to cover today. I will stay around until 3 o'clock and answer any more questions. If you're ready to leave, you can go ahead and depart. There's one more question here. Do you ever manually change the cards and run from the prompt? Yes, we do it all the time. Basically, this CM cards file is a text file. You can open it in any text editor, and this is what it looks like. Basically, there's all the cards that tell CMS how to run, what version it's running, where the files are located, where the data sets within the files are located, other information. So a lot of times we may come in here and we may change, the time step. Right now we're using 360 seconds. That's the default for the time steps. We may go in and change the output time list. So I can kill that and say I don't want it every 0.1 hour. Maybe I want it every half hour for output. And so I can save this and then rerun the grid or the run, and then it will take on the new aspects from what we actually just modified. Another question you mentioned, we cannot run telescoping grids in implicit mode, but we can outside of SMS. No, that's not what I said. What I said was you can run telescoping grids with the implicit model only, whether that's inside the SMS or outside the SMS. If we try to run a telescoping grid with the explicit model, then it does not know how to, it can't read the files, it doesn't know what to do. And so it'll error out very early. So you can run telescoping inside of SMS, outside of SMS, but only with the implicit model. Does that answer your question, Matt? Yeah, when we modified the control file, this parameter file, you'll see a difference in the time on that so that you know that there's been a change. All the other files were written at 240. This one's written at 249. But the only other way to tell that it's been changed is now I changed from writing out every 0.1 hours to every 0.5 hours. So you see there's only global output every half hour now. So that kind of tells you that you have been you have made the change and it's actually working. Another question is, what is the difference between CMS Flow and AdCirc? AdCirc is another numerical model that can be used in many types of situations. It's more of a regional type model. So a lot of people use AdCirc to model deep ocean basins running with hurricanes. There's various types of winds. We can run with similar winds in CMS, but CMS Flow is more of a local, not quite a basin-wide model, just because we have no geographic coordinates. It's on a flat plane, so we have limitations as far as that's concerned. Another difference between CMS Flow and AdCirc is that AdCirc has no sediment transport capability. They were adding it at one point, but there's been no effort whatsoever in recent years to add any kind of sediment transport to AdCirc. So if you want to run, see what's going on with sediment transport, you can't run AdCirc. Now you can run a combination of AdCirc and CMS Flow and get an AdCirc-based water surface elevation to force a smaller CMS Flow grid. We've done that in the past, but that's primarily the differences between AdCirc and CMS Flow, other than AdCirc is a finite element model using triangles, and CMS Flow is a finite volume method using rectangles. Another question is, can you say anything about what you will obtain from these output values? What are you looking for? I'm going to actually be covering reading in solutions on Thursday afternoon or Friday in the post-processing talk, and so I can talk about that a little bit more detail then. But basically there's various things that come out of this grid. I mean, you've turned on looking at water surface elevation, you've turned on looking at velocity components. On the day that I cover post-processing, we'll actually load a solution and I'll show how to visualize the results. You can build animations, build charts, graphs for reports, things like that. But I'll actually talk more about that on Friday. Another question was, what's the difference between CMS Flow and RMA2? I really can't tell you much about RMA2. I've never used that model. All I can say is that CMS Flow, you see what kind of model it is right now, and you can do some research on that model and on the RMA2 and see what the differences are. I wish I could help you more with that, but I have no experience with RMA models. Another question is, can you define cell strings in the middle of ocean cells and define flow and salinity boundary conditions to these cell strings to simulate a marine outfall? Right now, in SMS 11.0, you cannot. The only way to put cell strings is along external boundaries and at locations where there is a land and a water interface. So right now you can't just put a cell string out at the end of a pipe to simulate a flow out of a pipe. But we are adding in new features that are going to be available in SMS 11.1, where we will need to put some kind of cell string or be able to describe an inflow from in the middle of a domain. So I believe that this will become available in the next version. Another question, probably the last one or two before we finish for the day. Can you use a wave generation model such as WAM to generate deep water waves at your boundaries? I believe the answer to that is yes. You'd have to find some way to generate information from WAM to be able to apply to every cell in the grid. There may be other ways to do this that I haven't thought about. We're going to be covering waves tomorrow, and so I may reserve this question for tomorrow and ask our wave person, who I hope will show up tomorrow, to answer this question. Well, if there are no more questions, I think I'm going to wrap this up for the day, and we will be back on tomorrow afternoon at 1 o'clock p.m. Central Time. So show up if you want to come in a little bit early and ask some questions. I should be in the room probably 10 to 20 minutes early, and I'll try to have my other helpers there a little bit early as well to help answer some of these questions that came up today. So if that's all, I'm going to go ahead and close down the webinar at this time.